Hello everyone, welcome to Triaright, the new era of learning. This is Pack 365 in Module 6. Today we're going to learn about logistic regression in machine learning. So let's begin the topic. Logistic regression is a fundamental supervised machine learning algorithm, primarily used for binary classifications problems. It predicts the probability of an event occurring when the outcomes can be belong to the one of two classes, like example spam, not spam, S, no, 0, 1, like that. So logistic regression is a fundamental supervised machine learning, right? So it is an algorithm which primarily uses the for binary classification problems. It enhances the logistic regression, predicts the probability of the event occurring. That outcomes the predictions belong to the one of the two possible cases. So common examples for those binary classification, we have the spam, not spam, like spam emails, not spam emails, like that. Spam calls, not spam calls, the classification on emails or calls or something, either spam or not spam. Yes or no, determining it in a certain conditions, it meet or yes or no, with the customer click on ads or yes, no, we want to continue like yes, no, like that. So representing the two-digit categories like numerization 0 or 1. So unlike the linear regression where the predicts a continuous numerical output, logistic regression models the probability that a given input belongs to a particular class. It does it does this by the using the logistic or the sigmoid function or the squash that output of a linear equations into a probability value between 0 and 1. If the probability existed a certain threshold of that the input classifies into a one class, otherwise it's classified into the other class. So we have the logistic regression is a supervised machine learning algorithm used for classification problems. So this is a key point. Unlike the linear regression, which predicts the continuous value, it predicts the probability that an input belongs to a specific class. It is used for binary classification where the output can be one or two possible categories such as yes, no, spam, not spam, like we can take true or false or zero as one. So it uses a sigmoid function to convert the input into a probability value between 0 and 1. So what is the logistic regression? So we have predict the probability of the binary outcomes as no, 0, 1 or true, false. Like, so uses a sigmoid function to the map input to probabilistic 0 to 1. Ideal for classification task like input features which combines with the linear combination. So we can say that according to the graph, it is yes or no, or it is get the probability of 0 or 1, like the true or false, like we can predict. Types of logistic regression. Logistic regression can be classified into three main types based on the nature of the dependency variables. So we have binomial logistic regression. This type is used when the dependency variable has only two possible categories. Example includes yes or no, pass or fail, or 0, 1. It is the most common form of logistic regressions and it is used for binary classification. Okay, problems. So multinomial logistic regression. So these two are the most common uses in the logistic regression. Okay. So this is the used when the dependency variable has a three or more possible categories that are not ordered. For example, classifying an animal into a categories like cat, dog, or sheep. It extended the binary logistic regressions to handle the multiple cases. So we have ordinary logistic regression. These types is apply when the dependent variable has the three or more categories with a natural order or ranking. Example including the rating, low, medium, and high. It takes the order of the categories into the account of the modeling. So when it comes to the binomial logistics, so so we can see the types of logistic regression. So binomial has two cases, right? So yes or no, right or wrong. So, multinomial we has more than two unordered like classification cat, dog, and sheep. And, ordinal it has more than two orders like classifying low, medium, high. So binomial logistic regression, when you use this is the most common for the logistic regression. It uses the when the dependent variable has only two possible categories. Like we know that fall, fails, yes, no, zero, one classified like that. Purpose of the it is a special like specifically designed for the binary classification problems. When it comes to the multinomial, it has an inherent order of an among the animal types, like predict a person favorite color or a list of a red, blue, green, like a list of a car, like red, like sports car, sports bike, like anything with your list of the order. The purpose of extending the basic binary logic regression to handle the multiple unordered classes. Okay, so. Ordinal logistic relationship is nothing but it has a rating type like low, medium, high, and the customer satisfaction levels is very like satisfied, unsatisfied, or neutral, or happy, unhappy, like an average. Like we have some rating according to the dependency ordering it has. Okay, purpose of the specially takes an inherent order to the categorize into account when the modeling, which is a crucial because treating order categorizes and unordered categorizes. So it depends on the categories. Okay. So, what we know that linear regression is a simple, right? So we know the linear regression equation. So y equal to b plus b1 x1 like that. Okay, b1 into x. So we have multi-regression also. So it has a basic, so it has n term. So we have a input like salary and we have the predictions here. So the scattered dots are the points and the linear regression. We know that. So about the linear regression, predict the continuous values, use the best fit line, solve regression problems for it based on the straight line. So logistic regression is opposite, like predicting the categories classes is not predicting the continuous values, it's predicting the categories classes. Like whenever we want to detect, we want to predict the classes here, and we want to predict the values here, like upcoming future values, we want to predict in linear regressions, and what the current categorized classes we want to predict for the logic regression, right? So it use Sigmoid like S curve, solve classification problems. So a company has provided an offer by email to the customer. So we have action called yes and no. So this is the data sets. So according to our action, yes means one and no means zero. So we have find the scat line. Like if we follow the scat line, so we can say that if we have yes, so the line goes like this. Yes is considered yes, is considered zero has no. Like we have order set here zero by one, right? So according to we have yes and no. So for that, the scatter line began like this. So it is a S curve object. We can call it as S curve. So according to the in linear regression, we can find the straight line. But we can come when it comes to the linear. Sorry, here I did some. So according to here, we are discussing about the linear regression, right? So we're discussing about the first linear, right? So in actions we have for in linear we won't get the straight line, but in logistic we get the cross of S curved line. Okay, let's talk about linear regression. So it is the center of the point. Okay, it is the center of the point which measures. So it is action. It gets the center. Like here we get the curve. Okay, so starting and ending will be same, but here we get the curve line. So like see here. We can see here in this the form of here. So we can see here this is a logistic regression of actual form. So here the center point which we see here, so it actually curve the center line, like it's curved the center line like this. Okay, so when it's changed the formulation, so this is the actual formula of linear and it is a sigmoid function and it applies to the both, and we have a equation for it. This equation concludes the uh, this actual logistic regression. So here we have the logistic regression. So here we can see the outputs here. The x-axis, this is the x-axis, x-axis. So this x-axis is representing. Now you can see this is the x-axis here. Yeah? So this x-axis is representing the independent variable or feature in the simple logistic regression. Like it would be a single input variable. Okay. So here the y-axis. Okay. Here the y-axis. Okay. This is the y-axis. So this is the y-axis represent the logistic regression or the actual dependent variable, the binary classification. Okay. And we have a data scatter points. Like we have the scatter points here. So this graph is represented the casual or actual observation data point. Like the place is known as the place marks near the bottom of the close to the y equal to zero. So y equal to zero. So here we have the y. Here we have the zero, right? So here we have y equal to zero, or here we have y equal to one, right? So here we y equal to 0. So it instant here the value of the y equal to 0 which we have. So this is the nearest closest to y equal to 0 indicates the instance of where the actual outcomes from the given x value, right? So it is a no, like necessary it takes a no, not, false or 0. Like we represent no, not, not spam, like anything we can correct or incorrect or false or directly we can call it as 0. So like that it will. So for y equal to 1, which is the nearest to the top close to the y equal to 1, it instance the s. Spam, yeah, agreed, agree like that, yes, agree, correct, like that it represented. So, the sigmoid shape is the output shape of this is, actually, this is the shape, okay, this is the shape, we are continuing, this is the shape, right? So, this is the shape which calls curve, S curve, which is a logistic or sigmoid function. This is the type of, this mainly called as heart of the function, okay? So we have the is y equal to 0 and y equal to 1, right? So notice that x is increase. Notice here the x is increase their general trend, and the actual outcomes shift to the primarily low class, okay? Lower class to the primary upper class. So sigma of the S shape, okay? So here what we did is, so the logistic equation is inside the green rectangle, right? Here we have the inside this green rectangle. So this inside this green rectangle is the equation of the sigmoid, right? So we can take here 1 equal to p equal to p, this is a sigmoid, right? So here p represent for the prediction the probability of the dependent variable being the positive class, okay, y equal to 1, and p equal to 1 minus p, this indicates to this known as the odd, okay, the ratio of the probability of an event occurring. So here again, this is the logistic function, like known as a log odd 0 or 1. So here this equation, this equation belongs to BO is nothing but this is an intercept, okay, and B1 and B1 into B1 which is here. So this is the coefficient, okay, coefficient for the independent variable X. So they connect the equation shows the log odd. So the event occurring is the linear function of the independent variable F. So the sigmoid curve is the efficiently inverse of the logistic function transformed to the linear prediction back into a probability, right? So the overall the diagram that efficiently how the logistic regression uses to the logistic function to the model that relationship between an independent variable, okay, x and the y probability of a binary outcomes like y. The S-shaped sigmoid curve usually represent the probability of the showing how the transparency for the 0 to near 1, okay, x changes allowing to the model of the classification data points, one or two more categorized, okay. So I hope you guys understand these topics. So we have some few examples like probability, how to detect the probability of p hat. So we have the probability cases, and we have the probability percentage here, which part, which tracks, in which part which is triggered to us. So like that, in which triggers and 50 predicted and probability values. So this is a dividend of y equal to 0, y equal to 0, and y equal to 1, 1, like the curved S-shaped, which is the nearest data point, to the half of the middle point. Okay. So if you guys all understand about this topic, so now moving to the some basic code. So it is nothing huge. Just we want to import some data sets from the breast cancer about the data sets and the scale, and from the logistic regression, we're creating a model here. So import train test fit. Okay. So matrix accuracy score. So this is a basic code of it. So just we want to finding not an actual code. Just we want to finding accuracy logistic rate accuracy model. Okay. So we can say we run this code and we see the accuracy of the logistic regression. So it has a 96.49. Okay. So it is a, binomial logistic regression. Okay. So actually we can see here. So in it we find right binomial logistic regression here it is, and actually it is. So this is multinomial. So it is actually multinomial. Okay. Multinomial logistic regression. So actually it represents the how the accuracy state of those. Okay. So this is 96.66. It has a 96 of average. So this is how we want to like testing the data and training the data. Okay. And it comes to the prediction from the linear model. So we have the basic prediction for the logistic regression here. So just a simple code of NumPy calculation about the code. So we get the predicted value here 0 according to the graph. So I hope you guys all are understand about this topics. So thank you.